Welcome to my fourth tutoring session in A-level chemistry. In this video, I'll give a detailed explanation about atom and subatomic particles with suitable examples. Here's an overview of my fourth tutoring session. I'll begin my session with introduction to atom. This will be followed by a detailed explanation about subatomic particles, protons, neutrons, and electrons. Later, I'll give a brief talk about importance of protons, neutrons, and electrons with suitable examples. And finally, I'll end my session with summary. Atom is the smallest unit of an element. It has a central nucleus which contains positively charged protons and electrically neutral neutrons, with the negatively charged electrons traveling around the nucleus in their respective shells or energy levels. Now I have color coded the subatomic particles with yellow referring to the positively charged protons, purple referring to the electrically neutral neutrons, and blue referring to the negatively charged electrons. Let me begin with hydrogen atom, as it is the first element in the periodic table. Hydrogen atom has one proton in its nucleus and only one electron in the first energy level or the K shell. It is also the valence shell, as hydrogen atom has only one energy level. So hydrogen atom has one proton in its nucleus, one electron in the valence shell, and it is the only atom in the periodic table without a neutron. And most importantly, it is the first element in the periodic table. What is a proton? Now, a proton is nothing but a hydrogen ion without a electron. Now, these two terms, hydrogen atom and proton, they are very closely related, and it may be a bit confusing to students who are beginners in chemistry. So hydrogen atom has one proton in its nucleus and one electron in its valence shell, while hydrogen ion, it has only one proton in its nucleus without any electron. Any given atom, it is the attraction and balance between the positively charged protons present in the nucleus and the negatively charged electrons in the energy levels is what keeps the atom electrically neutral and stable. Why protons are positively charged, neutrons are electrically neutral, and electrons are negatively charged? Now the answer to this question lies within the subatomic particles. In case of proton, we find another set of subatomic particles called quarks, and these quarks, they have an electric charge. Proton has two up quarks and one down quark. Now up quark, it has an electric charge of plus 2 by 3, while the down quark has an electric charge of minus 1 by 3. And these quarks are held together by another set of subatomic particle called gluons, and gluons have no electric charge. When we add up all these charges, we end up with plus 1. Therefore, plus 1 is the total charge of a proton. So now you know why proton has one unit positive charge. Now in case of neutron, it has two down quarks and one up quark, and these quarks are held together by gluons. When we add up all these three charges, we end up with 0, and 0 is the total charge of a neutron. So now we know why neutron is electrically neutral, though it has charges within its structure. So quarks and gluons are different types of subatomic particles. Quarks make up protons and neutrons, while gluons are responsible for holding these particles together in the nucleus. Protons consist of 3 quarks, 2 up quarks and 1 down quark, while neutrons consist of 3 quarks, 1 up quark and 2 down quarks. Now the quarks are held together by gluons. Like protons and neutrons, quarks can have a positive or negative electric charge, while gluons have no electric charge. Now coming to the third part of the question, why electrons are negatively charged? Now the answer to this question goes back to the origin of electric charge in case of electron. That is, we have to go back to the discovery of electrons from cathode rays. Now, cathode or negative electrode emits cathode rays, and there were charged particles present in these cathode rays, and in the presence of electric field, these charged particles, they deflected towards the positive plate, proving beyond doubt that these charged particles are negatively charged because they are deflecting towards the positive plate. And later it was discovered that these negatively charged particles are nothing but electrons. Now we already know that proton, it has a unit positive charge. So if proton has a unit positive charge, definitely the electron will be having a unit negative charge, because it is the attraction and balance between the positively charged protons and the negatively charged electrons is what keeps an atom electrically neutral. So they mutually cancel each other, giving a net charge. Let me give a detailed account of the subatomic particles: proton, neutron and electron. Now proton is positively charged, electron is negatively charged, and neutron is electrically neutral without any charge. Now when you compare and contrast the mass of proton and neutron, you find that neutron is slightly heavier than proton. So when you observe the third decimal of neutron, you find that it is 5, and in case of proton it is 3. So neutron is slightly heavier than proton, though its ratio of mass is 1, both in case of proton and neutron. Now when you compare and contrast the mass of proton and neutron with electron, you find that proton and neutron are nearly 2000 times heavier than electron. You can put it the other way around, saying that electrons are 2000 times lighter than the mass of protons and neutrons. And because of the negligible mass of electron, we do not consider it in the atomic weight calculation. We tend to ignore it. So we tend to ignore electron because of its negligible mass. Now let us consider the nucleus of carbon atom, which has 6 protons and 6 neutrons. Now protons, as you know, they are positively charged particles present in the nucleus, and we also know that like charges repel each other, and these positively charged protons, they would naturally repel each other due to electrostatic force. Now the strong nuclear force is an attractive force that overcomes this electrostatic repulsion between protons in the nucleus. Now protons and neutrons are held together in the nucleus of an atom by the strong nuclear force. It's also known as the strong interaction or strong force. So it is responsible for binding of protons and neutrons within the atomic nucleus and plays a crucial role in the stability of matter. Now the strong force operates over extremely short distances, which is why it's effective only within the confines of the atomic nucleus. Now let us discuss in detail about the importance of subatomic particles, protons, neutrons, and electrons. Let me begin with the importance of protons. Now protons are positively charged subatomic particles present within the nucleus of atom, and they play a vital role in determining the atomic number and also defining the chemical identity of the element in the periodic table. Let us consider the nucleus of sodium atom, which has 11 protons in its nucleus. So the proton plays a vital role in determining the atomic number. What is atomic number? Atomic number is nothing but the number of protons present in the nucleus of that particular atom. Now, for example, in case of sodium atom, there are 11 protons in the nucleus. So all the atoms with 11 protons are nothing but sodium atoms. So any given atom with 11 proton will be sodium atom. Now, second important role played by proton is that it is helpful in defining the chemical identity of the element. Now, the proton gives the identity to the element in the periodic table. Now, for example, hydrogen has one proton because its atomic number is 1, making it the first element in the periodic table. Carbon has 6 protons in its nucleus, making it sixth element in the periodic table. Nitrogen has 7 protons in its nucleus, making it the 7th element in the periodic table. And oxygen has 8 protons, making it the 8th element in the periodic table. So sodium will be the 11th element in the periodic table because it has 11 protons in the nucleus. Now let us have a closer look at the third period in the periodic table. Now third period starts with the sodium element. Now sodium is the 11th element in the periodic table because it has 11 protons in its nucleus. Magnesium is the 12th element in the periodic table because it has 12 protons in its nucleus. Aluminium has 13 protons in its nucleus and therefore is the 13th element. Silicon is the 14th element because it has 14 protons in its nucleus. Phosphorus is the 15th element because it has 15 protons in its nucleus. Sulfur has 16 protons in its nucleus and therefore is the 16th element. Chlorine is the 7th element in the periodic table because it has 17 protons in its nucleus. And the inert gas argon is the 18th element as it has 18 protons in its nucleus. Now moving on to the importance of neutrons. So what are neutrons? Neutrons are neutral subatomic particles found in the nucleus of an atom. They contribute to the mass of an atom and can impact stability. Furthermore, neutrons determine the isotopes of an element. Now neutrons, they play a vital role in determining the isotope of an element. And secondly, it also plays a crucial role in stabilizing the atomic nucleus. Now let us try and understand how neutron determines the isotope of an element with an example. Let us consider carbon as an example. Now naturally occurring carbon contains 98.89% of carbon 12, 1.11% of carbon 13, and negligible or trace amounts of carbon 14 isotope. Let's begin with the carbon 12 isotope. The carbon 12 isotope, its atomic number is 6 and mass number is 12. Why its atomic number is 6? So when we look closer into the nucleus of the carbon 12 isotope, we find there are 6 protons in the nucleus and 6 neutrons. And therefore, atomic number is 6 and mass number is 12. So atomic number is number of protons in the nucleus and mass number is the sum of protons and neutrons present in the nucleus of that particular atom. So the nucleus of carbon atom contains 6 protons and 6 neutrons. Therefore, its mass number is 12. Now moving on to the second isotope, C13 isotope of carbon atom. Its atomic number is 6, mass number is 13. So why its atomic number is 6 and mass number 13? So when you look closer into the nucleus of the C13 isotope, we find that there are 6 protons and 7 neutrons. So moving on to the least stable isotope of all, that is C14 isotope. Its atomic number is 6, mass number is 14. So why atomic number of C14 isotope is 6 and mass number is 14? Because when you look into the nucleus of C14 isotope, we find there are 6 protons in the nucleus and 8 neutrons. So when we compare and contrast these 3 isotopes, we find one thing in common, that is the atomic number. So atomic number is same. So the number of protons remains the same in case of these 3 isotopes, while they differ in terms of neutrons. So there are 6 neutrons in case of C12 isotope, 7 neutrons in case of C13 isotope, and 8 neutrons in case of C14 isotope. So neutrons can vary in number within the nuclei of atoms of the same element, leading to the formation of isotopes. So isotopes of an element have the same number of protons, that is they have the same atomic number, but different number of neutrons. So therefore the neutron determines the isotopes of an element and it also adds to the nuclear mass without introducing a charge. So though there is adding up of neutrons in case of these 3 isotopes, we do not find any charge. So the adding up of neutrons in case of C13 and C14 does not introduce any charge. So C12 isotope has 6 neutrons, C13 has 7 neutrons, and C14 has 8 neutrons in its nucleus. And of these 3, C12 isotope is the most stable, as you can judge from its content, and C13 is less stable, and the least stable isotope of all is the C14 And neutron, it also contributes to the or accounts the stability of the atom. So neutrons help stabilize the atomic nucleus by adding to the nuclear mass without introducing a charge. And most importantly, they counteract the repulsive force between the protons, preventing the nucleus from breaking apart and impacting its stability. Now, moving on to the most important subatomic particle of an atom, that is electron. Now, electrons are negatively charged subatomic particles that orbit the nucleus of an atom. They determine the chemical behavior of atoms and are involved in bonding with other atoms. What are the major functions of electrons in an atom? Firstly, they determine the chemical behavior of the element. So electrons are responsible for an element's chemical reactivity. So it is the arrangement and distribution of electrons in energy levels or the shells which decides how an atom will bond with other atoms to form molecules. And about chemical bonding, so electrons are involved in the formation of chemical bonds. For example, in water molecule, so electrons are shared between hydrogen and oxygen atoms, leading to the molecule's unique properties. So in case of water molecule, you can see that electrons are equally shared between hydrogen and oxygen atoms. And thereby the oxygen atom is covalently bonded to two hydrogen atoms. Now, for example, in case of sodium, it has 11 electrons. The outermost electron of sodium, it plays an important role in its reactivity. So when sodium reacts with chlorine, it loses this outer electron to form a positively charged ion, that is sodium ion, leading to the formation of common table salt, that is sodium chloride. Now, it is the valence electrons that are present in the outermost shell plays a crucial role in determining the chemical property of that particular element in the periodic table. Now, sodium has one valence electron and therefore it reacts with one chlorine atom. Magnesium has two valence electrons and therefore it reacts with two chlorine atoms. Aluminium has three valence electrons and therefore it reacts with three chlorine atoms. So electron, they play a vital role in determining the chemical behavior. So electrons are responsible for an element's chemical reactivity. The arrangement and distribution of electrons in energy levels decides how an atom will bond with other atoms to form molecules. Let us consider some examples to understand this concept. Let us consider the formation of compounds with non-polar covalent bonds like hydrogen, fluorine and chlorine. Formation of compound with a polar covalent bond like in case of hydrogen fluoride, and formation of ionic bond like in case of sodium chloride. Now in case of hydrogen molecule, fluorine molecule and chlorine molecule, we see that there is equal sharing of electrons between the two atoms involved in bond formation, and therefore they are non-polar molecules because the electrons are evenly shared, and that results in formation of a non-polar covalent bond. Well, in case of the formation of hydrogen fluoride, we find that there is unequal sharing of electrons between the two atoms because fluorine is highly electronegative atom with electronegativity of 4, and therefore there is unequal sharing of electrons between these two atoms, resulting in formation of a polar covalent bond, and therefore hydrogen fluoride is a non-polar, it is a polar molecule. So gaseous hydrogen reacts with gaseous fluorine to form gaseous hydrogen fluoride. Now similarly, Sodium reacts with chlorine to form sodium chloride. Here in case of sodium chloride formation, we find that sodium is losing its electron in its valence shell to the chlorine atom, resulting in formation of sodium chloride. The second example will be formation of solid magnesium chloride from solid magnesium and gaseous chlorine. Now magnesium has an electronic configuration of 282 with 2 electrons in its first shell, 8 electrons in its second shell, and 2 electrons in the valence shell. So it reacts with 2 chlorine atoms which has an electronic configuration of 287. So magnesium loses one of its valence electron to first chlorine atom. It loses its second valence electron to the second chlorine atom. And this results in formation of magnesium ion, which retains the or attains the electronic configuration of neon. And the chlorine, it gains one electron each from magnesium, and thereby it attains the stable electronic configuration of argon. And overall, it results in formation of a stable compound, that is magnesium chloride. So here we see the change in oxidation state of magnesium from 0 to +2 and change in oxidation state of chlorine from 0 to -1. So what is the driving force for magnesium to lose 2 electrons? So magnesium loses 2 electrons to attain the stable electronic configuration of neon, while chlorine atoms gain 1 electron each to attain the stable electronic configuration of argon. One more example, formation of solid aluminum chloride from solid aluminum and gaseous chlorine. Aluminum has 3 valence electrons and therefore it reacts with 3 chlorine atoms. It loses 1 electron to each chlorine atom. And these 3 electrons will be only from the valence shell. And this results in formation of stable compound aluminum chloride. Now aluminum has lost 3 valence electrons to 3 chlorine atoms and therefore its oxidation state changes from 0 to +3, while the chlorine atoms, each chlorine atom gains 1 electron with change in oxidation state from 0 to -1. So what are the key takeaways from my today's session? Atom is the smallest unit of an element. It has central nucleus that contains positively charged protons and electrically neutral neutrons with negatively charged electrons orbiting around the nucleus. Proton has another set of subatomic particles called quarks, and these quarks are held together by gluons. And same in case of neutron. Neutron also contains subatomic particles called quarks, and these are held together by gluons. Now, protons and neutrons are held together in the nucleus of an atom by the strong nuclear force, and they play a vital role in the stability of matter. The energy associated with the strong nuclear force, called binding energy, is what holds protons and neutrons together within the nucleus. Now, this strong force, it operates over extremely short distances, which is why it's effective only within the confines of the atomic nucleus. Quarks and gluons are different types of subatomic particles. Quarks make up protons and neutrons, while gluons are responsible for holding these particles together in the nucleus. Finally, to summarize, protons, neutrons, and electrons are the building blocks of atoms, and their functions are integral to understanding the atomic structure, chemical behavior, and the uniqueness of each element in the periodic table. Protons and neutrons are primarily found in the nucleus and contribute to the atom's mass and stability, while electrons are located in the energy levels and determine an atom's chemical properties and reactivity. So these three subatomic particles work together to define the properties and behavior of the elements in the periodic table. Thank you so much for watching my video. Hope you enjoyed it, and I'll see you in my next interesting tutoring session.